All right, we are back. We are looking at section 2.3, chapter 2 note packet for Math 200. I'm Mr. Pledgey. This is my TA C3PO, and we're going to get into solving equations for a specific value. So we're on page 7 of the note packet, and now look, this doesn't look like math, it looks like English. Look at all those letters. So we've got T equals MNR, and they want us to solve for N. So N is going to be the only one that we treat like an actual variable. So here, let's go to the off board here. What if instead of that, what if I had an easier equation like, oh wait, that's probably up too high so you can see it. We'll go over here. Or a little lower. 12 is equal to 4n. So if we had that, let's see, can you see that? 12 is equal to 4n. So if we had that equation, we would divide both sides by 4, and then 3 would equal n. So you always divide by the number that's in front of the variable. To isolate, you want to isolate the variable and make sure there's a 1 in front of it. That's a coefficient of 1. When there's nothing there, there's a 1 there, all right? So on this one, there aren't numbers to divide. So a lot of students think that they're doing it wrong. We divide out, we want n equals. So we divide both sides by mr. This is, you're probably too young to get this one, but it's Mr. T. He was a fictional character on a show called The A-Team in the 80s. And I think they did a movie also that it was probably just a silly. So anyway, T over mr is equal to n. That's our answer. That's it. So like when we did it up here with numbers, it makes more sense because you said 12 divided by 4 equals 3. And then we could take 3 and pop it back in and say 3 times 4 is 12. Here, it's a little more abstract. This is called an abstract problem because there isn't a numeric value answer. It isn't just like 7 or -3 or 5/8. It's T over mr or rm. It doesn't matter if you put the order the other way around. All right? Okay. So let's look at 2. We've got 3y minus 2x equals 7 for y. So now look, we have two variables here. And again, I'd like to look at a problem that's maybe a little bit easier, where if instead of this, if we had 3y minus 5 was equal to, I don't know, let's make it -17. Now that's not related to this problem, that's just a two-step algebra problem. So what would we do for that one? We would add 5, and then we would divide by 3. So y would equal -4. That would be how we would do that two-step equation. We isolate the variable, get rid of the 5, so now we got 3y all by itself, and then we divide by the coefficient, the number in front, to get 1y equals -4. And that's the answer. We are going to do the same thing here, but usually your brains are going to throw up a bunch of mental barriers, meaning it's going to feel wrong. You add 2x to both sides. And right now, here comes the first barrier. People look at that and go, well, I screwed up. Because 7 and 2x, I can't add those together. Those are unlike terms, so I must have made a mistake. Because here, it was -17 and 5, and I put them together and I got -12. This isn't wrong. This is correct. So we've gotten rid of the 2x off of this side. And so we have just 3y on this side, on the left side. And on the right side, we have 2x plus 7. That's it. We've got that. Now, look at what we did second over here. We divided by 3, and we had -12 divided by 3 is -4. And that was our answer, just a single number answer, an integer, all right? Here, we can't do that. It's 3 on this side. I want 1y. I still want 1y. But when I divide it, it doesn't look done. I mean, it's done. We got y is equal to 2/3 x plus 7/3. That is the answer. That is the correct answer. But it feels wrong because I couldn't combine those terms because they were unlike terms, and I couldn't divide because 3 didn't go into 2 evenly and 3 didn't go into 7 evenly. This is correct. The object of the game was get 1y equals. It's still get 1y equals. They identified y as the thing that we're going to treat like a variable. All the rest of these we treat just like they're regular numbers in order to get to that end game of 1y equals. Okay? So it is tricky. These do take practice. Now, number 3 is especially hard because we're going to have to do something that rhymes with tractor. P-R-T. Okay, so they want us to solve for P. There's a problem. I can't add those two together. That has an RT on it, so it's unlike terms with that one, which just has a P. So what I have to do is factor out a P. Remember what factoring is. Factoring is doing the distributive property, but in reverse. So instead of multiplying it in, let's think about what the distributive property looks like. If I have 5 times x plus 7, the distributive property means I take 5 times x and 5 times 7, and I get 5x plus 35. If I want to do the reverse of that, I look at 5x and I look at 35 and I say, what can I factor out? What goes into both of those? That would be 5. And then I divide it out of that, I get x, and I divide it out of that, and I get 7. So going in reverse, the distributive property in reverse. So I look at this, I got P and PRT, so I could factor out a P. So you write it down, you do an empty set of parentheses, and then whatever you wrote down out front as the common factor that you're going to factor out, you write it underneath each one, and then you reduce it term by term. So now be careful. What is P divided by P? That is 1. What is PRT divided by P? Well, the P's cancel and just get RT. So now I have this. I have P times quantity, 1 plus RT, and it's equal to A. But I don't want that. I want just 1P equals. So just like what I did here, where I divided out the 3 on both sides, or just like what I did here, where I divided the MR out on both sides, or just like what I did here, divided the 3 by everything, what I'm going to do is I'm going to divide this entire thing out. So it's called a binomial. Those are two unlike terms inside a set of parentheses being multiplied by a variable out front. That's a binomial because there's 2 terms, and they're unlike, so I can't add them together. But if I divide both, the top has it on there, and I'm divided by the bottom, that's being multiplied. Look at what happens. Those cancel away. So I end up with just P equals, and then I got A over 1 plus RT. Now, this is fine. If you write it like this, you can write it like that. That's fine. If you're one of those people that like to write it like this, that's okay. But if it's written like this, you need to put parentheses around it to show that this whole thing, this whole binomial, is in the denominator, not just the 1. All right? If you write it like this, you don't need the parentheses. You can put them there. If you feel better about having parentheses on it, have parentheses on it. It's fine. But you don't have to do it. Remember, we're lazy in math and try to write as little as possible. If you've got the big long line like this, that's fine. If you don't have the big long line like that, if you have the little divide by sign like this, you need to put it as in parentheses so we know the whole binomial is on the bottom and not just the 1. All right? Okay, on to word problems. We love word problems. So let's take a look at Oh man, I was hoping this board was gonna erase super easy all the time because I got a brand new whiteboard. But this time, this run, it's kind of hard to erase. I'm putting a lot of elbow grease in here. So let's read the problem while I'm erasing. Charles Piquet can afford enough fencing to enclose a garden with a perimeter of 140 feet. If the width of the garden is supposed to be 30 feet, so probably like he's on a city block and it's 30 feet wide. So it's going to be like the width of his yard. What does the length have to be? Find the length. Okay. So we did a problem like this in class. And that was a little harder, actually. This one's a little easier. So first, draw yourself a picture. So here we have the garden. And it's going to be, the width is going to be 30 feet. And then the length, we don't know, but it's going to be X, and that's going to be X up there. So remember, perimeter means adding around the outside. So this was a problem that I told you. I want you to label, when it's perimeter, I want you to label every side of the rectangle, even though those are both 30, and even though those are both X. So look, X plus 30 plus X plus 30 has to equal 140. Is that it? Yep, 140. I don't want to put the wrong number up there. All right. So now we combine like terms. We combine like terms on the same side of the equal sign. So there's a 1 there, even though we never write it there. There's a 1 there. So 1x plus 1x is 2x. 30 plus 30 is 60. And then equals 140. Now again, throughout my career, I've answered a lot of questions on these kind of problems where I've had students go, wait. On the other one that I already erased, you were subtracting. So why didn't you say minus 30 and minus 30 and then there's 0 there? It's just 2x equals 140. Well, think about it. I subtract at this stage in the game. First, I'm just cleaning this up. I'm combining like terms and getting it all nice and neat on the left side, and the right side was already nice and neat. It was 140. Now I get to start solving the problem. Now I get to say, okay, isolate the variable. That means get x by itself, and that means subtract 60. So because these are the same side, that's why I just combined them and I got 60. That was on the same side. I combined them, I got 2x. If this would have been over here, then I would have subtracted it off and the 30s would have disappeared. All right. Okay, so we move the 60 over. It's kind of like moving it over, like you move it across the equal sign and it becomes a negative, or you can think of it as subtracting 60 from both sides of an equation. So this equal sign always just rides straight down. That goes away, so I just have 2x there. That's 80. And then I have 2x equals 80, but I want 1x equals, so I divide by 2, and then x equals 40. Now, I've had, so that's in what, feet? 40 feet? 40 feet. So the length is 40 feet. I've had students go, no, Mr. Pledger, I looked in the book and they had this, 2w plus 2l. That's fine. This is the formula for perimeter. If you want to do it this way, it would still shake out to be exactly the same answer. We would put in 140 for perimeter. I would put in the width as 30. I would put in the length as x. And 140 is equal to 60 plus 2x, which if you look at that very carefully, that is exactly what we had right there. So if you prefer to use the formula, use the formula. If you prefer to do it as an addition problem, combine like terms and then simplify, do it that way. Personally, I think that way is a little easier because this can get a little bit more hairy if you have to do the distributive property and stuff. So here, we'll finish her off for you in monochrome, one color. Okay, cool. All right, let's look at page 8. A flower bed is in the shape of a triangle with one side twice the length of the shortest side and the third side 30 feet more than the shortest side. Find the dimensions if the perimeter is 102. So it's perimeter again, so we're adding around the outside. And so when we talk about a triangle, you're just adding length plus width plus height, kind of like three things, not length, width, and height, I guess. Just the three sides of the triangle, X and Y and Z, all the way around. This one was different because it was a rectangle, so we had duplicates. So let's look at, ooh, blue erase is really good. It's this other marker is giving me trouble. Okay. So here goes. We've got three lengths of a triangle. So let's draw a triangle. And it's not necessarily a right triangle, that's just what mine looks like. So the shortest side is going to get to be X. Why does the shortest side get to be X? Because the other two sides are described in terms of the shortest side. It says one side twice the length of the shortest, the third side 30 feet more than the shortest. So since they both reference the shortest, I guess on my picture that's here, X is the shortest side. And then they just said one side is twice that length, and the last side is 30 plus that length. 30 feet more than, so X plus 30, or 30 plus X, doesn't matter which one. And so now see this one, we definitely would want to just say this plus this plus this. So X plus 2X plus X plus 30 is equal to the 102 feet. Again, there's a 1 there and a 1 there. We combine like terms. We have 4x plus 30 equals 102. We subtract 30 from both sides. 4x is equal to 72. We divide by 4. So half is 36. Half of that is 18. So x equals 18. But we're not done. That is just the shortest side. We need three sides. So that means we're going to have to go back and say, well, 2x, which is 2 times 18, which is 36. And what are we in? Are we in feet? We are in feet. So 18 feet, 36 feet. And then the last one is x plus 30. So you go back to that one, so 18 plus 30. Don't accidentally use the 36. That's a very, very common error. 48 feet. And so there are our three sides, 18 and 36 and 48. And then if you want to check that, those should add up to 102. And so if I add those together, we get 14, carry the 1, 84, and then 84 and 18, 12, carry the 1 is 102. 102, yay! So it checks out, 18, 36, 48. All right. Marielle Callier just received an inheritance of 10 grand. Oh boy! And plans to place all the money in a savings account, pays 5% quarterly to help her son go to college in 3 years. All right. How much money will be in the account in 3 years? So this is different than the simple interest rate that we did in the other section. This is compounding interest. So what that means, in a nutshell, is when you compound interest, what happens is you make that calculation for interest, but then you add that money, the interest, into the total amount, and then you calculate the interest again the next time that it's supposed to be calculated. And then you add that interest in. So it's like accumulating as you go. It isn't just, we did simple interest, where we just did it times 5 years and said, this is what will give you an interest. This would actually be a little bit better of a deal, because you're figuring out the interest, adding it to the total, and then figuring out the interest of your original money with that extra interest in there. So it actually grows a little tiny bit faster. All right. But that also means that the formula is a little more complicated. So this one I did just remember out of nowhere because I taught math with business apps for a while, and we use this one a lot. All right. So there's an extra step in it. It isn't just 1 plus the rate to the time times P. Or no, I think interest, we did interest before where we just did interest equals, this is what we had before. Get rid of that guy. Interest was equal to PRT. That was just to calculate the interest. This formula actually calculates the money with the interest accruing. So this one's a little bit better, but it's also a little more complicated. So let's take a look. We've got P, that's the principal amount. That's how much you shove it in there. So that's 10 grand. We got R, that's the rate. Now remember, we don't just leave it 5. That's a very common mistake. People leave it 5. That would be 500% interest. That would be probably something illegal would be going on if you're getting 500% interest. So we take it 2 places to the left, make it into a decimal so it can play with the real numbers. So it's 0.05. Now we have an extra, T is still time. And they wanted to go 3 years, that's fine. But now we also have N. N is the number of times it's compounded in a year. So if that were done every year, just once a year, N would be 1. And then it wouldn't really affect anything because 1 times the time would just be 3 still. And R divided by 1, that would just be 0.05 again. But it isn't. It says it's compounded quarterly. Well, think about quarters. 4 quarters in $1, right? Quarterly is 4 times a year. They also have semi-annually or biannually. Those are both mean twice a year. They also have monthly. That's obviously 12 times a year. Or annually, that's once a year. All right? So quarterly looks like that. So now it's just plug and chug. So 10,000. 1 plus 0.05 divided by 4 to the 4 times 3 power. So again, we're going to do order of operations, parentheses. Within the parentheses, we're going to divide first. So when I divide that out, I get this. Still the 4 times 3 power, and still 10,000 there. That still equals A. 10,000 here. Still, we add now parentheses 1.0125. You can multiply that and make it 12. You could do that right away if you really wanted to. You could have that 12 sitting there. But now you've got to be careful. Order of operations. That is the order in which we do all mathematics. And that means we do exponents before multiplication. This means multiply. That's exponents. This one wins. Please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. But we don't always multiply before we divide, and we don't always add before we subtract. Those are kind of a left to right thing. Or really, it's the same operation. I'll explain that later. But parentheses first, did it. Exponents next, gonna do it. So we do those exponents. And that's 1.160754518. We're talking about money, so let's not round it all. Let's put that whole thing, leave that whole thing in your calculator. If you type that into your calculator, this is what it'll kick out, and then just hit times 10,000, and then we'll round to the nearest penny here. But in reality, banks don't round, they just truncate. So look, even though this is a 5, banks wouldn't give you a 55 cents, they'd give you a 54 cents. So $11,607, and whichever way you do it, I'm going to just round 55 cents. You can just do normal rounding, that's fine. Just in the real world, they don't round up. All right? Cool. The next video I shall be doing is 2.4.